for attending this session. We will be covering about cloud-native real-time data solution that provided by DataStack. The principal data architect from DataStack, I am under APJ, but I mainly cover for ASEAN markets. So a bit tricky. I also cover for Taiwan. So it's not really ASEAN, but those are the regions that actually will be covering, like for Vietnam, Jakarta, Indonesia, Jakarta. So it'll be Bangkok and Manila. We are actually expanding to that also. And of course, myself is based in Singapore. I know I do sometimes don't look like Singaporean, but I'm a pure Singaporean, by the way. So I've experienced for actually more than 10 years as a middleware specialist. So actually moving to DataStack as I'm curious about being as a data architect. Is it different from as a middleware? And doing middleware for more than 10 years, I'm actually looking for some new region. So just sharing some of the background that I have. So these are the agenda for today. We will actually cover what is DataStack. Maybe if you all don't mind, maybe just have a show of hand. Anybody heard about DataStack before this event? Okay, thank you. So next I will be covering about our solution that we can cover around event-driven architecture, application modernization. Okay, this naming sounds very middleware, right? But it will be more of our real-time solution that we are providing that can relate with the middleware portions. As I'm more of a middleware background, so I actually would like to share my experience and solution based on this portion as in for data streaming, database for streaming, and also some real-time AI, and together with how to merge with the middleware portions. Welcome. You can take a seat. I don't bite you. Can take the first row. So include real-time data skills, where the scalability of a database is actually very important for organization. No matter how powerful is your middleware, your microservices architecture, you still need to have a powerful and scalable, high available, zero downtime kind of database. So the last demo. Okay, I will start off DataStack. Yeah, thank you. So from DataStack is a US company. We are actually, the head office is in San Francisco. It's actually in Santa Clara in San Francisco, California itself. So we are actually started from 2010, about 13 years. And our founder started with Cassandra, Apache Cassandra. So Apache Cassandra, our founder is the main contributor, and now we are still the main contributor with our engineer on that. So we start off with providing solution for database NoSQL. Later we extend to providing solution for streaming. And now we actually move to actually the machine learning AI/ML portion, which we just bought over a company called Cascada. And we are actually moving our solution to provide real-time AI. So AI, AML is not new. I mean, it's recently the trend, everybody is moving to data analytic portion. They need to have a way of to get their data, streaming their data into a scalable kind of platform in the database to actually powerfully can process the, your data with the AI/ML model. And our solution actually is available. Okay, it's available in the popular, three popular cloud. It's like AWS, Azure, Google, and we are running on Kubernetes. So both our solution that is based on the streaming. Okay, our streaming solution is based on Pulsar. So can I have a show of hand of anybody actually heard about Pulsar? Okay, I believe a lot of people in the room definitely heard about Kafka. It has been out for 10 to 15 years. So Kafka is, Pulsar is something that released by Yahoo. Yahoo is the one that Kafka. And after some time, they realized the disadvantage about Kafka. So something called Pulsar, and actually contribute this solution into the community. And of course, DataStack also participate I'm not sure whether on or off. Is it better to use the, where's the organizer? So, okay, sorry. So it will be a case where we are actually provide enterprise support for Pulsar. We also have our managed service for streaming release in this popular cloud provider with the Pulsar solution. And of course, we start as a database company. So we are actually having our managed service as Astra DB that is based on Apache Cassandra. And on top of this, of course, now this event is about API. So we do have a layer, what we call as a data gateway, for you to provide a means to access your data beside the typical of driver, SDK. You also can access your data through API. So REST API, I think now not a lot of people using SOAP anymore. So more people, actually most of people that I talk to, the customer, partner, all actually is using to REST API. And some of them actually start to use GraphQL API. Of course, the document API is not new in the market. So like MongoDB, normally they will be using document API, Cosmo, those Dynamo kind of database. So we also support to interact using the gRPC. Okay, I think now it's a trend. A lot of people is using Golang to actually implement their application, which is more lightweight. So a lot of people use, I actually do have a customer who's already using the gRPC, and of course the CQL protocol, the API, for you to interact with the database. For customer, for organization, migration is always a pain, a consideration that people have. So if they're moving from GovCraft, okay, I'm not personally attached to GovCraft, it's just that it's an enhanced version of GovCraft, so besides that. So it will be a case where migration is a concern. So we come up with this layer called Starlight, and we are actually contributing to Pulsar. That is from DataStack portion. So if any implementation using Apache GovCraft, RabbitMQ, JMS 2.0, API standard API, you can actually just change the endpoint of the original cluster you're talking to Pulsar. So there's no change to your application in terms of the API. You just need to change the endpoint, and you can actually migrate it over to use Pulsar as your streaming solution or your messaging solutions. So this is something I myself actually wrote a blog that actually changed from GovCraft to Pulsar, and how easy is that? Oh, by the way, okay, I will share my link up later on. So you can feel free to contact me that I can share my blog. Actually, my blog is in the Medium, so you can actually find the article over there. So this, as I said, is a managed service. Everything will be handled by DataStack. In terms of the infrastructure, the operation, the scalability, it will be handled by DataStack itself. And if you have concern about, let's say your business is actually covered from US to Australia, in India, in Singapore, you can have, in this both solution, you can have your data available in multi-region, multi-cloud also. So let's say for today, let's say example, just an example in a way that Azure give a discount like 50 for next 2 years subscription, so everybody just move over to the other cloud provider. But it's not so easy when you want to move. But in a way that if this solution is available in these 3 clouds, it's make your solution more portable. And for Cassandra, it do have a CDC capability, change data capture. So for those that don't know what change data capture is, a way of if there's an insert, update, delete, a change to your data in the tables. So those will be captured as an event, change data, and push it into streaming. And you can actually push it to your downstream system. It can be another Cassandra. It can be also to maybe Elasticsearch for other processing, Snowflake, for example. So you can push to other downstream kind of solution. So I will explain more that we not only can talk to Cassandra, we also cover other kind of scenarios. So recently, actually, we bought over a company, Cascada, that actually provide the AI/ML portion. So we are actually moving towards to the regions. So you can actually get your data from different sources, stream the data, and actually store into our data for fast processing with your AI ML model, with your as your feature store engine also. So in a way, we start off the company as a contributor Apache Cassandra, and we are moving towards to actually Pulsar, and actually we just open source Cascada. So to actually get feedback from the community, how to answer our capability. So we actually contribute whatever that we have to the community itself. And we start as a database, and we move on to event streaming. And it's a platform that event streaming and also for messaging or queuing, the terms that general people will use. And also now we move on to the machine learning and AI ML portions. Question? If not, I will move on to the next chapter. Okay. So data-driven architectures. So when you talk about data-driven architecture, people will talk about more middleware background. So you will be talking about microservices. Microservices best practice is to actually use streaming messaging to decouple your services so that they can actually scale independently. That can be one case. The other case is like, for example, your shopping app. So if you bought something or you need to be informed of certain promotion, etc., that it can be captured of an event that is happening, then it will trigger an alert to maybe to the buyer or to the seller itself. So when we talk about event-driven kind of architecture, we will trigger about real-time application. When we talk about real-time application, microservices architecture that I shared just now is one means. It can be using the streaming Kafka, which also streaming kind of mechanism, or using JMS, RabbitMQ. A lot of people using different kind of solutions. So we are actually having a streaming solution that can cover for both event streaming, data streaming, whatever you want to call that. It can also have for messaging and queuing purpose. So you can use it with your mobile app for IoT, Internet of Things, and how that works. I will cover that in details. So we come up with our solution, Astra streaming based on Pulsar. So Pulsar, actually the main difference that I like as a technical person is they break the dependency between the broker, which is the one to serve the read and write request, and also the bookie. Okay, sorry. So that is the main thing that can make this part to be more scalable. You can scale up and scale down without having the need to have this storage information to be moved in parallel with your broker. It makes itself more scalable. Okay, I have a diagram later on to actually show that. And also, of course, we have the Zookeeper to store the metadata information. Yeah, sorry. So like I mentioned, we actually come up with a layer, contribute to the community called Starlight. With this Starlight, you can actually, with minimum, I won't say that it's totally zero. It's still a configuration. Typical of implementation, last time I do middleware, we actually put the config endpoint in config file, a common place to change, so that I don't change everywhere in the code. So unless you are putting your IP endpoint, IP address and port everywhere in the code, then you need to change the code more tedious. If you are like putting in the common place, you just need to change the property file or whatever you call it to actually like in Kubernetes world, your config map. If you just change your config map, the particular value, you can just change your solution instead of pointing to the original JMS provider, Kafka or RabbitMQ, you can actually switch to Pulsar to actually deal with those Pulsar advantage. So if you are using solution like the JMS with like Oracle JMS, IBM MQ, Tico EMS, or maybe also IBM MQ. Of course, the thing is if they are using JMS 2.0, we support for JMS 2.0, we can do the migration easily. So this streaming solution, it not only for the pub sub, it's not only for the streaming, it's also for the queuing. So if you want to configure for date letter queue, or you want to do a retry, all this configurable can be done here. And I will show later on the flexibility of different consumption patterns. And we do support for the CDC that I mentioned earlier, the change data capture. This change data capture here I'm covering is not only for Cassandra. Of course, for Cassandra, because of its nature, it will actually, to make sure there's no loss of data, we replicate data. So we do work together to make sure that there are no duplicate data being streamed over. So that is the solution that we have. But of course, this CDC that you're seeing here, if you have solution like working with traditional database like Oracle DB, SQL Server, MySQL, PostgreSQL, or MongoDB, and you need to do the change data capture over there, then you can actually, it will be, we do have the available connector which is based on DBASM. So from there, it can be synced over to Pulsar and push it to the downstream system you like. So similarly, we also have provide a capability called functions. So you can do the necessary kind of enrichment, transformation, or filtering, or cleansing of data before you actually pass it to your downstream system, or you pass to another topic for further processing. We do support for multi-region. Like I mentioned earlier, you can have your data in Singapore, you have your data in Mumbai. So it's no need to actually having to cluster is a multi-region thing in same set of data. So that we do that with a dual replication. And this dual replication is a two-way. A two-way of replication. I will have a more detailed slide later on. So we also support multi-tenancy as compared to the one that I mentioned, the existing streaming solution which commonly adopt that doesn't have a multi-tenancy concept. It's a single tenant. It's like one organization. You happy or not, that the whole world can see all the topics they are having. So there's no isolation of the ownership. So the common one will be a case where you produce a message and this information will be shared across, across to the same subscription with different consumer. That's a typical one. Or you can actually base, like Kafka can do also, or based on some key, based on the key to actually get the same set of information. So on top of that, actually what Pulsar have is it have the exclusive. So in exclusive in the way that if you are using that subscription A, there only one consumer can use this subscription to get your data. So this is a kind of requirement may not be able to fulfill last time before we have a Pulsar solutions. So the other one is failover. So in the way that if B1 is still up consuming the data is okay. If it fails, actually the B2 can continue to consume the data on the solutions. And this is not a existing solution that has been available for years. Okay. For us, we do have a native support with the Astra DB CDC. So it's very easy. You just in the Astra DB integrate which table you want to enable it as a CDC, change data capture. It will be pushed to Astra streaming, and the Astra streaming is the one that pushed to the downstream. It can be to another Cassandra. It can be down to maybe sync to Snowflake processing, going to other relational database. Same thing for other relational database or MongoDB, another NoSQL database. You can get the data and stream it through Astra streaming and push it down to Astra DB. Okay, so in a way, just to give some high-level kind of introduction, what we different for the GovGov. So GovGov, you will normally will have different partition, and each of the partition actually is tied to a broker. So when you want to scale out to have another broker, you need to have the storage there, and you need to do rebalancing, and that requires downtime. So in the way of Pulsar, we actually, for the partition log, we actually segment the data. So it's not tied to the broker and also the bookie is not tied together. So you will be actually replicate the data to different bookie itself. So to make sure the data is still available. So in a way that if, let's say, your this 4 bookie is all full, you can actually anytime add another bookie 5, and the data will start to distribute to this bookie 5. So it makes your scalability more easy. And same thing if you need to scale up for your broker, you can just spin up another VM, for example. If you are this, you can actually spin out as another pod to serve the request. So with support for multi-tenancy, it can be at the tenant layer. It can be at the namespace layer where you can set like the quota of the storage, that how many consumer or producer going to use the message size. You can set all those to protect your respective kind of tenant under the own department or division, for example. So dual replication is something that I mentioned earlier. As long as you have access to these are 3 different clusters. As long as you configure that this particular producer can actually connect to this cluster A and C, for example. So you can actually push the data when it's being write to A, you will push to C also. The topics need to be there also. And if you need to keep track down to the subscription, means the consumer portion, you also keep the subscription state in sync. So this is something that people will look at when you are having a GovCuf. You need to actually make sure the offset point, keep track of that. Is quite difficult to do it. So this is something that provided by Pulsar itself. All this what I share here is a feature capability that is provided by Apache Pulsar. It's not actually proprietary by DataStack. It's all available there. And of course, according to the GigaOM, there will be cost saving to actually replace GovCuf with Pulsar. So it can be up to 81%. And this article, actually, if you Google, you can easily find this article and see the cost saving that you're having. And if you are running on our Astra streaming, based on pay as you go. So you only pay for how much you use. So next is about the application modernizations. Okay. In a way, I go the cycle of this modernization. So last time, people were like, if they need a queuing kind of solution, they will look for those messaging queue like JMS, WebLogic JMS is a typical one, or using the IBM MQ. So subsequently, people start to actually look for like having a publisher subscribe. And then that is actually under topics, under JMS also. It's a queuing and topics kind of mechanism. So subsequently, people start to release middleware solution with enterprise service bus. So that is one that organization will actually use their own messaging kind of solution as part of the solution to actually read for certain event that is happening and process that. And next we start to have GovCuf coming in and different flavor of GovCuf to actually serve the different kind of requests. And as the cloud coming out, also the cloud have their own flavor kind of messaging solution, or maybe their own flavor of GovCuf that is coming out. So also with the IoT needs, the needs of talk to MQTT kind of protocol. So as this grow, your solution will become like this kind of network, complicated kind of connection to pass data from here to there. It's very actually hard to maintain for those people doing the day 2 operations. So what we have is like the one that I mentioned. We do have the Starlight layer where you can actually easily migrate your solution that can support both streaming and messaging that you need. And you actually with minimized code kind of changes. And of course, what we have now is GovCuf, JMS, RabbitMQ, and we are working towards to the MQP and MQTT. So if any of y'all need this kind of solution, feel free to talk to us. We can explore that with you. Yeah, this is the one that I covered. Yeah. So next, actually, our solution, of course, we also provide for database, and our database is based on Apache Cassandra. So itself is based on distributed architecture. It's not based on master-slave kind of architecture. So every of the nodes that you're seeing here is able to serve the read and write requests. And our data is actually recommended to minimally replicate 3. So it will be distributed. So if one is down, at least 2 copy of your data will definitely be available. And we do support what column data model. So what it means is just like the normal relational database where you have the key and you have other attributes like my key is my NRIC, so my name, my age, the address I'm staying, for example. But it's a way of how we store it into the Cassandra. It makes the read and write actually easier. So we based on some key, what we call as a partition key, to generate a token, kind of token here to know that which of the nodes to actually store the data and where are the replicated data going to store. So it's designed to be high availability and there's no single point of failure. So this is what I mean by there are some other solution, no matter it's NoSQL or SQL solution, they have a master-slave kind of concept. So it is only the master that is serving the read and write request. And if there's this leader is down, this master is down, it will take about, depends on solution, second or millisecond to actually identify the next slave to be the master. So it's still some kind of single point of failure. You need to take maybe a few seconds or a few milliseconds to identify who is the next master. And Cassandra itself is distributed, like I mentioned. Every of these can serve the read and write request. So you no need to depend on one single node. So when the data is in, it will actually, by default, the best practice is a replication of 3. Of course, if your cluster is bigger, we have different kind of recommendations. So you will write in, it will be right into the 3 different nodes also. If this node is not, at least your data is still available here. And if you need to handle more and more transactions, let's say I have 3 nodes that can handle, assume can handle 100K of transaction per second. So as I increase to 6 nodes, the number of transactions you can handle is double, etc., etc. That is what we are doing. And as the Azure should be maintained by us, we actually do the monitoring by our SRE behind to make sure that we the number of nodes that we deploy, the pods, is able to handle the transaction as you required. So our solution can be hybrid cloud or multi-cloud. You can actually sync your data across different clouds. Of course, the normal case is more of let's say AWS, you want to actually have your data available in Singapore and Mumbai and US. So you can actually deploy your database in a way that you can select it to be a multi-region and it will be available everywhere that you need it to be. So our Azure DB is already available. It's already available in AWS, Google, and Azure. In AWS, we have that in Singapore region. So indeed in region and US is available for the 3 cloud, of course. So you can easily just create the database, which I'll be showing in my demo later on. And you are not tied to particular cloud provider. So like for example, the one that I gave earlier, if Azure suddenly give a promotion the next 2 years, new subscription or cheaper by 50%, which unlikely will happen. For example, yeah, so everybody will actually swap and move over to the other cloud provider that's cheaper. So we are actually dynamic elastic. We will actually scale up and scale up according to the workload that your business, your application required. So you will be paid as you go. You won't be like a case of, okay, everybody going to manage service. A lot of people going for pay as you go structure. So it's a typical one of you pay for what you need. You no need to like if on-premise, last time we will need to provision like so many servers just for the peak time. And the peak time maybe only happen once a month. Yeah, for example. So that helps to reduce the cost. And of course, we do have the Stargate layer for you to have a wide range of API where you can select to implement your applications. So for here, what I want to share is our Astra DB is actually run on Kubernetes. So we break the dependency between the broker, the compute to serve the read and write, and the storage. So it can scale more dynamically. It's not like Cassandra when you're running on VM. It's actually tied to the storage. Although we have a replicate mechanism, but it's more tied to the storage that is running on the same VM itself for access, etc. So for this one, Astra DB actually we break it in a way that we break the compute and the storage, and we are actually using S3 to store the object. So it's actually make it more cost optimizations. So this Stargate here, what I want to share is that we, like API layer, we support the different kind of programming language. So Java is a common one. I think Golang is the new trend that everybody is doing it. And Python is a common language that all the data scientists need to use for their AI/ML kind of modeling. And we support data model, include the white column family that I share, the document and the key value portion. And we are coming up with another Astra solution, which is currently on-premise. It's going to be on cloud that is based on the graph. And that's one thing coming up. For Cassandra, is well known for indexes, we have secondary index. Now, for the DataStack, we come up with something called storage at text indexing. So the difference is it can support more than one column. So for example, if you create a table like here, personnel with ID, first name, last name, age, and the start date, and the key is the ID itself. So when you want to do a age as a search, it will fail. And of course, if you put it as a secondary index. But we come up with a solution which is a better performance in terms of the spacing of storage, also more optimized. It's called storage attached index. And with that, you can actually search your data based on this. So you can support actually up to 10 columns for the per tables itself. So this is, I talked to quite a few customers about this. Really like this capability because they are not to only the secondary index that normally Cassandra only have. And we are contributing this into Cassandra also. And our Astra DB solution, if you have consideration of going through the internet to access the database is in our Astra DB, you can actually go through the private link support. We do also support for PPC peering that is using our other offering that is called Astra Classic. You also can limit the IP address can access your DB. And we are using the intrusion detection and preventive to mechanism, some tools inside, make sure nobody attack your database. We support single sign-on, role-based access, and also we support for end-to-end kind of encryption. It can be data arrest, data in transition, and if you prefer to use your own key, like most of the cloud, at least those three that I know of, they have their own kind of key management. You can use that for your encryptions. And for those developers, they need to authenticate themselves before they talk to your database. So we do have a automatic token generation to make sure that they will access the database through the token itself. And we do have audit log to check against the administrative kind of action like adding user, adding role, for example. And we do have a set of get drill to this well according to the recommended standards. And we also, this is again based on GigaOM that if you use Astra database, the serverless database, it helps to reduce the TCO by 85% compared to your self-managed kind of database. So if you are using your existing own Apache Cassandra for now, you can actually consider to talk to us to move to Astra DB. This is already available in Singapore, in AWS. And also in the AWS, we actually can consider to make it as a PCI compliant if there's needs. So lastly will be my demo. So my demo scenario is a kind of straightforward cases. I talked to a couple of bank or insurer or that. One needs where now a lot of people need to consolidate data. They consolidate data to have a customer 360 view and process to do analytics of the data to see that what other better service they can do for their customers. So for simplicity, I actually using the API to actually use Spring Boot, use the API to push the information into Azure streaming the topics. And the first scenario what I have is use out-of-the-box connector to actually push the data into Azure DB. So the other scenario that I have is same thing using API, but this case, we need to actually transform the data such that they can write into the Azure DB. The main thing I want to show here is that there's API capability, and also we have an out-of-the-box kind of connector and a means for you to actually do transformation as required. Okay, just some IT typical experience. Sometimes you want to do real-time kind of demo, things will happen. So I will do it as a video. Of course, if you all would like to see the real kind of demo, you can actually come to our booth. I'll arrange a time with our sales. They will arrange for me to actually do demo for you. Okay, give me a second, let me switch.
Okay, let's start with the demo.
My voice a bit
To access this Azure console, you can go to, Azure.datastack.com. And this is where you can actually sign in with the free trial, getting USD $25 free per month to access both Azure streaming and Azure DB and its service. Let me sign in using my Gmail.
This is not clear. I just repeat the part that was important. If you sign in, register, there's a 25 USD free per month for you to use our solution for Azure DB and Azure streaming. So there's no credit card required. You will not problem for that. But the catch is that for the free tier for now, we are open for Google Cloud USD one. Yeah, so in case it's not very clear.
So I'm sorry, if the time allows, I will actually walk through the introduction of this Azure console with you. For now, I'll focus on the demo. And for this demo, I've created a DB called Bank DB. And for the streaming portion, I've created another instance called Bank Demo Stream. So then we start with the bank database, Bank DB. So under this Bank DB, I've created a key space called transaction. Let me use the SQL console, which is similar to your SQL console with your relational database to access your data. And for this demo, I will use the transaction key space, and we can use the describe transaction to just show that what are the tables created in this key space and like the configuration for this key space. So for the first scenario that I will be showing, I'll be using this transaction by account, just to show you that it is empty. And let me get up this Postman that will be calling Spring Boot applications. which will pass this content into the streaming, which in turn to write into the Astra DB via a sync connector. So let me do a send. And this, you will see the data is inserted. You can see the information is clear as the parameter that I pass in here. So this is a kind of straightforward demonstration of how the APJ application can work with the streaming and also the extra DB portions. So that's the second scenario is to write data in a less straightforward kind of structure, where this is like the parent information of this person having these two accounts. So how to how to actually make this to write into the Azure DB. So we are using the function that is in the Azure streaming to actually transform the data in a way that it can be written into the tables that is in the Azure DB. Here, let me get this table account by CIF, where you have the person unit ID and the account that the person have. So how do I transform the message from the JSON format into here? So similarly, let me show to you the tables is empty. That's all. Now. So next I will be using similarly Postman to actually calling my script application to actually push the data into the streaming, and the streaming actually will go through the function to push the data into the Azure DB. If it's successful, you will see the data being populated into the DB itself. So this is just to illustrate that no matter how the source data structure will be like, you can use the function to actually transform the structure data accordingly so that it can be written or pushed to the downstream target that you need to. For this case, is Azure DB. So in the streaming portion, we do have I've already created earlier under the POC namespace to actually create the two topics. And this transaction data feed will be the first scenario, and CIF data feed will be for the second scenario. So for the first scenario, we are using a sync connector, where you can define a sync connector, let's say, to use this Astra DB, and from which topic going to listen to, and also which database you're going to talk to, and do some mapping or defining how the data is going to map accordingly. And similarly, that we have a function where this function can be written like Java, Python, and Go. And with that, you can actually kind of jar the application and upload into as a function into Azure streaming. And when the message is processed, it will consume for the CIF data feed, and this is where you will merge the data accordingly. That's all for the demo. Thank you.
Okay, but what I want to explain here is that if you want to do a data consolidation, this is one of the tools that you can use. That's all to share. Is there any question? Okay, to be honest, we just GA this extra streaming product. So actually now we are actively working with different opportunity that we can actually get. So if you are interested with this solution, actually I can talk to you separately to catch up to understand of your requirement. Then we can explore from there. Yeah, this solution will just GA this year. Yeah, but actually this is widely already used by Yahoo. I also have already a customer. It's not a very big scale, but they are using it for microservices kind of architectures. So as a microservices using streaming to actually sync between the microservices. So that will be the case. I've a lot of banking and finance talking. We are still talking. It's not close. I cannot disclose their name, but in a way that they are very keen in the data consolidation. That's why I'm showing the demo here because using that. Because that's the most common case that I see beside the microservices. And I do have customer have a concern about GovCov. So those points that I mentioned there is already an out-of-the-box feature by Pulsar to support that capability. So you have a needs you want to explore rather than just GovCov-based solution. Also Pulsar, we can have a check on that. Yeah, to know of your requirement and how do we meet your needs. Yeah. Sorry? Attention? Or retention. Yeah, it's the same. In a way, you can actually configure the retention period of your data. Okay, when people move from messaging to GovCov, it's because they need to retain the data. They need to replay. So this is a case of in Pulsar, you also can configure to actually do the retention. It's the same thing. And the same thing, it can also, okay, it's the same thing for messaging and also streaming portion, but we break the architecture by the broker and the storage to make it actually more scalable. Because GovCov scalability is, over the years, people start to realize that it's actually a problem. Yeah. 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 Yes, we do support enterprise support for on-prem also. So the on-prem you can run on your Kubernetes or run on VM. So all this is supported. Looking at the time because I need to pass to the next speaker. So thank you for attending the session. I have my name card over here. If you all need to some technical clarification to know more about our solution, we do support for on-premise and also on cloud. But now more customer is moving to cloud, so my subject is more on native data solutions. But we do support for on-premise also.